Hello, welcome back. Today we're going to be solving and graphing inequalities in 1 and 2 variables, and this is a unit summary. By the end of this video, you should be able to solve and graph linear inequalities in 1 and 2 variables. So to get us started, I've got a couple of linear inequalities for us to solve. Now, if you already know how to do these, please go ahead and try to work them on your own. Pressing pause and press play when you're ready to see the answer. If not, let's take a look. In order to solve for x in this first inequality, we treat that greater than or equal to sign as if it were an equal sign. And we just get x, I'm going to go ahead and box that, by itself. So to get x by itself, I'm going to subtract 8 from both sides. Give me 4x is greater than or equal to, 2 minus 8 is negative 6. Go ahead and divide both sides by 4. Give me x is greater than or equal to 3/2. Now to graph it, I'm going to put 3/2 on a number line, and a number before that, and a number after it, just to give me the direction of the number line. Now for greater than or equal to, since x can actually equal 3/2, we're going to use a filled in circle on 3/2. Now, since x is greater than or equal to 3/2, we're going to shade all of the values on the number line that are bigger than or equal to 3/2. So we're going to shade to the right. Now for the second one, again, we're going to get x by itself, so I'm going to go ahead and box x, letting me know I need to subtract 9 from both sides, giving me negative 6 is bigger than negative 2x. Now we're going to get x by itself, so we're going to divide both sides by negative 2. Negative 6 over negative 2 is a positive 3. We have x on this side. Since we divided both sides by a negative, hopefully you'll remember that means we need to change the direction of that inequality symbol. So we're going to change it from greater than to less than. Going to draw ourselves a number line, put 3 on it, a number before and a number after to give us the direction. And since x cannot be equal to 3, it's just greater than, we're going to draw an open circle to represent that we cannot actually equal the number 3. Now we get to look at it. Is x bigger than 3 or is x less than 3? Well, since x is on the bigger side of this symbol, it means x is larger than 3, so we're going to shade towards all the numbers that are bigger than 3. Now let's take a look at a couple different ones. The one on the left, again, if you know how to solve these, please go ahead and solve them, pressing pause and press play when you're ready to see the answer. Now, this inequality on the left, notice that x is in the middle, and we've got two different inequalities on either side of the x in the middle. That means we're going to try to get x alone in the middle, and whatever we do to the middle, we've got to do to the other two sides. Now I've got a negative 2 next to some parentheses. I can either distribute the negative 2, or I can divide all sides by negative 2. Now since it's a whole number, I'm just going to go ahead and distribute that negative 2. Give me negative 2x. Negative 2 times negative 5 is a positive 10, less than 8, and greater than or equal to negative 4. Continuing solving, I'm going to subtract 10 from all three sides. Give me negative 14 is less than or equal to negative 2x, which is less than negative 2. Still need to get x by itself, so I'm going to divide all three sides by negative 2. Give me negative 14 over negative 2 is a positive 7, x in the middle, and a positive 1 over here. Now since we divided all three sides by a negative number, we need to change the direction of those inequality symbols. I'm going to graph that down below here in a little bit. Actually, let me go ahead and graph that right above what we just got through doing. So to graph this, I'm going to make a number line, and all I really need to include are the two numbers that are part of my inequality, the number 1 and the number 7. 1, since x cannot be equal to 1, I'm going to use an open circle. Now for 7, since x can actually be equal to 7, I'm going to use a filled in circle. Notice that x is between those two values, so we're going to shade between the two values. You can always check to make sure you've shaded in the correct spot by choosing a number in between 1 and 7, such as 2. 7 is bigger than or equal to 2, which is bigger than 1. That lets us know we've probably shaded in the right direction. Let's take a look at the second one. Negative 2/3 x is greater than 8. To get rid of the negative 2/3 on x, we're going to multiply both sides by a negative 3/2. So the negative 2/3, negative 3/2 cancels, giving me x, since we multiply both sides by a negative, is less than, and I'm going to clean this up a little bit. I'm going to rewrite it up here. 8 over 1 times negative 3 over 2. You can multiply straight across, top to top and bottom to bottom. Gives us negative 24 over 2, or negative 12. So this is the left-hand inequality of this entire statement. X is less than 12, negative 12 rather, or we still have to solve this right-hand one. So to do that, we're going to look at it completely separately. So we're going to get x by itself. I'm going to subtract 4 from both sides, giving me x over 5 is bigger than 4. And then we don't want x divided by 5, so we're going to multiply both sides by 5, giving me x is bigger than 20. So our final statement is x is less than negative 12, or x is bigger than 20. If I were to ask you to solve, you would have to write that entire statement because all of that is part of the same solution. In order to graph it, we put down our two numbers, negative 12, positive 20. For negative 12, we use an open circle. For positive 20, we use an open circle as well because x cannot be equal to either one of those numbers. Now x is less than negative 12, so we shade to the left, or away from negative 12 towards numbers that are smaller. And x is bigger than 20, so we're going to shade towards numbers that are bigger than 20. And there you go, you have solved and graphed an OR inequality. By the way, on the left-hand side, the one that we solved and graphed is called an AND inequality because x is greater than 1 and x is less than or equal to 7. The right-hand side inequality is called an OR inequality because x is less than negative 12 or x is bigger than 20. Now we're going to review graphing all the solutions of inequalities on a coordinate plane. Now the instructions right here to remind us what kind of line to make. If y is greater than mx plus b, or y is less than mx plus b, then none of the points of the line are solutions, so we make a dashed line. Now, notice that it doesn't say or equal to. Again, that means you cannot equal any of the points on the line. So again, we use a dashed line to signify that none of the points on the line are solutions. Now, greater than or equal to, or less than or equal to, in this case, all of the points on the line are solutions, so we make a solid line to signify that all of those points, again, are solutions. Shading is fairly straightforward. If y is greater than or equal to mx plus b, then all the ordered pairs above the line are solutions, so we shade above the line. Now, if y is less than or equal to mx plus b, then all the ordered pairs below the line are solutions, so we shade below the line. Let's go ahead and take a look at our first inequality that we're going to graph. If you know how to do this, again, pause the video, work it out, and press play when you're ready to see the answer. If not, let's take a look. In order to graph, we're going to want to get y by itself and get the equation in what's going to look like y equals mx plus b. Now, it's not going to be equal to, it's going to be some inequality symbol. Let's take a look. In order to get the y by itself, we need to get rid of these parentheses right here, and I'm going to do that by distributing the 2. Giving us 3x minus 6 is bigger than 8 minus 2y. Now I can get y by itself by subtracting 8 from both sides. Give me 3x minus 14 is bigger than negative 2y. Then I can divide everything by negative 2. All the terms on both sides, giving me 3 over negative 2x minus 14 over negative 2 is plus 7. Now it's going to be less than y. It's less than because we divided both sides by a negative sign, which caused the inequality symbol to change directions. I'm going to rewrite that a little bit better. 3 over negative 2, or negative 3 over 2, x plus 7. So let's plot our y-intercept first. Our y-intercept is 7. We plot 7. And we're going to use our rise over run. Up 3, 1, 2, 3, to the left 2, 1, 2. Or, since it's a negative, we can go down 3, 1, 2, 3, to the right 2. Either way, the point should line up in a line going down because our slope is negative. Now you got to think to yourself, is it going to be a solid line or a dashed line? Now it should be a dashed line because y is greater than, not greater than or equal to. So we're going to make a dashed line through those points. And y is greater than, so we're going to shade above the line. This means all of our solutions to this inequality are the ordered pairs above the line. Alright, go ahead and try to graph this one on your own, pressing pause and press play when you're ready to see the answer. Now we still need to get y by itself, so we're going to subtract 2x from both sides. If you'd like, you can always box the y, and remember that you solve in sad enough order, so we subtract and add first. So we subtract 2x from both sides, giving us 5y is less than or equal to. Now I'm going to write my negative 2x first. And since that's a positive 10, I'm going to write plus 10. Now I still need to get y by itself, so I'm going to divide everything by 5. Give me y is less than or equal to negative 2/5 x plus 2. My y-intercept's 2. My rise over run is negative 2 over 5, so I can go down 2, 1, and right 5. 1, 2, 3, 4, 5. Down 2, right 5. Or I can go up 2, left 5. Up 2, left 5. Either way, you should get a straight line going down because your slope, again, is negative. Now, since y is less than or equal to, we're going to create a solid line through our points, signifying that all of the points on the line are solutions. Now, since y is less than or equal to, we're going to shade below the line. And there you go, you graphed your second linear inequality. And for the last couple problems, we're going to graph a couple inequalities that are a little special. X is greater than negative 3 and y is less than or equal to negative 4. Now x, if it were x equal negative 3, we would create a vertical line through negative 3. So it's still going to be a vertical line. You just got to figure whether it is solid or dashed. Now it's going to be dashed because x is greater than, not greater than or equal to. And since x is greater than negative 3, we shade all of the numbers or ordered pairs that have x values bigger than negative 3. And that would be all of these to the right of the line. Now, y is less than or equal to negative 4. We're going to create a solid line. And in this case, the y value has to be negative 4 always. So we're going to create a solid line through negative 4. Now our y values are less than or equal to negative 4, so we're going to shade all of the ordered pairs that have y values less than negative 4, which would be these down here. There you go, you've graphed a couple of special linear inequalities. Because I call them special, they don't have both variables, they just have one variable, and they create these graphs right here.